The strangest thing in Earth's history is not the rise of humans, but that only one human species survived. Homo sapiens were never the strongest, fastest, or most numerous. So why did every other human lineage disappear, while we became the dominant species on Earth? Around 7 million years ago, the last common ancestor of humans and chimpanzees split into two different evolutionary branches. From that moment on, the history of the human family was nothing like a ladder with step after step rising upward, as many old textbooks once described. Some species appeared and then disappeared. Some species coexisted for hundreds of thousands of years. Homo sapiens was only one of many branches that once grew from that bush. What created that complex evolutionary network? Over the last 3 million years, the climate of this continent repeatedly shifted between wet and dry periods, driven by changes in Earth's orbit combined with global climate transformations. Dense forests shrank and expanded many times. Savanna grasslands spread far and then gave way to trees again. Lakes formed and then vanished. Imagine a community living around a large lake in East Africa. When a long drought arrived, the lake slowly dried out. One group had to move north, another moved south, while others crossed toward the west. Tens of thousands of years spent living in different environments caused them to accumulate their own genetic traits. That is why more and more paleoanthropologists support the Pan-African origin model. According to this model, Homo sapiens was not born in a single cradle in East Africa, as the traditional view suggests, but formed from a network of ancient human populations spread across Africa, constantly connecting and exchanging genes with one another. Archaeological discoveries over the past 2 decades have strongly reinforced that picture. In 2017, scientists announced fossils from Jebel Irhoud, Morocco, dated to around 315,000 years ago, now considered among the oldest known Homo sapiens fossils. What is astonishing is that this site lies more than 3,100 miles, or about 5,000 kilometers, away from the regions of East Africa. Meanwhile, the Omo-I fossil in Ethiopia has been dated to about 233,000 years old, while Herto is about 160,000 years old. Genome analyses of thousands of modern people show that Africa today still has the highest level of genetic diversity in the world, reflecting a long evolutionary history in which many populations once lived apart and then repeatedly blended together. And yet, if we could meet the first Homo sapiens, we might be surprised by how familiar they looked. They already had relatively flat faces, skulls that were rounder than those of earlier Homo species, bodies adapted for long-distance walking, and hands skilled enough to make refined stone tools. They knew how to hunt, gather, exploit many food sources, and survive in very different environments. However, for tens of thousands of early years, they were still only one human species among many others. If modern appearance, skillful hands, and the ability to make tools were still not enough to help Homo sapiens dominate the planet, then what created the turning point? For decades, scientists once believed that the larger the brain, the higher the intelligence. But fossils have told a completely different story. The brain of Homo sapiens today has an average volume of about 82 cubic inches, or around 1,350 cubic centimeter, while many Neanderthal individuals reached between 88 and 98 cubic inches, or about 1,450 to 1,600 cubic centimeter. And yet, around 40,000 years ago, they disappeared, while Homo sapiens spread across almost every continent. That shows the decisive factor was never simply a larger brain. The skull of Homo sapiens tends to be rounder, reflecting a restructuring of the brain during development, especially in the parietal region and the cerebellum, areas linked to information integration, planning, memory, and the coordination of complex cognitive activities. However, Homo sapiens seems to have possessed a special advantage: the ability to connect many separate ideas and create entirely new concepts. Homo sapiens could sit around a fire, imagine a hunt that would take place many days later, predict that a herd of antelope would move with the seasons, calculate how much water to carry, and divide tasks among each member before the hunt began. Imagine a group of hunters around 70,000 years ago. They did not chase after prey the moment they saw it. They observed footprints still pressed into the ground from the day before, read the direction of the wind, chose an ambush point many miles away, and then waited patiently. But the greatest wonder lay in another ability: symbolic thinking. Homo sapiens began to see more than what their eyes could observe. Archaeological evidence at Blombos Cave in South Africa shows that from around 75,000 to 100,000 years ago, Homo sapiens had carved geometric patterns onto ochre and made shell beads to wear on their bodies. These objects did not make hunting more efficient, nor did they create more food. Their value lay entirely in symbolic meaning. It was a sign that humans had begun to think beyond the physical world in front of them. From that moment on, the human brain did not only remember facts, but also created invisible realities. Rules, honor, belief, gods, and later money. Nations and science could not be held, weighed, or measured. This was one of the most important turning points in evolutionary history. Homo sapiens could connect much larger communities through shared symbols and shared beliefs. That variability opened the way for division of labor, trade, religion, states, and eventually the entire civilization of humanity. However, for the cognitive revolution to truly change history, those thoughts had to be transmitted with increasing accuracy from one brain to another, from one generation to the next. And that was when Homo sapiens possessed the most powerful technology ever to appear on Earth: language. This was not merely a tool for communication. It was the first technology that allowed knowledge to be stored, copied, and improved without waiting for genetic mutations to accumulate over thousands of generations. Humpback whales sing songs that can last for tens of minutes and travel for dozens of miles through the ocean. Honeybees perform the famous waggle dance to indicate the direction and distance of flowering plants. Vervet monkeys produce different alarm calls when they spot eagles, leopards, or snakes, and each sound triggers a distinct response from the entire group. These systems are remarkably sophisticated, yet they all share the same limitation. They primarily communicate what exists here and now. Humans can recount a hunt that took place years earlier, describe a valley hundreds of miles away, warn of a danger that has not yet appeared, or discuss an idea that has never existed in the physical world. This trait is nearly unique within human communication systems and forms the foundation of all long-term planning. A few spoken sentences could transfer experiences accumulated over many days to listeners who had never lived through them themselves. For the first time, knowledge became separated from personal experience. A stoneworker who discovered how to strike two different types of rock to create a sharper blade no longer had to carry that secret to the grave. He could teach it to his descendants, pass it on to others in the tribe, and generations later it could be refined into spears, javelins, or arrows. In evolutionary biology, this phenomenon is known as cumulative culture. But the greatest power of language was something even more extraordinary. It allowed humans to tell stories. What bound people together was no longer blood alone, but shared narratives: who their ancestors were, who owned the land, which rules must be followed, and why people were obligated to protect one another. More importantly, everyone believed in those stories. That became the foundation of every human society that followed. The archaeological record reflects this transformation with remarkable clarity. From roughly 100,000 to 40,000 years ago, archaeologists observed a dramatic increase in jewelry, pigments, beads, cave art, figurines, and burial rituals across many regions of Africa, Western Asia, and later Europe. Even more remarkable is the fact that the brains of modern Homo sapiens are almost indistinguishable from those of their ancestors who lived approximately 40,000 years ago. Yet for the first time in Earth's history, knowledge became a form of inheritance more powerful than DNA itself. And once knowledge could be accumulated, corrected, and passed forward, rather than endlessly restarted from the beginning, a new force emerged. Faster, more flexible, and powerful enough to shape an entire planet. Cultural evolution. It was this force that would carry Homo sapiens out of Africa and begin the conquest of nearly the entire world. For nearly 4 billion years in the history of life on Earth, every species had to adapt by the same rule. Wait for random genetic mutations to appear, then let natural selection decide which mutations would be preserved. But with Homo sapiens, another path appeared for the first time. Instead of only changing the body, humans began changing knowledge. And what is astonishing is that knowledge can evolve far faster than DNA. Anthropologists call this phenomenon cumulative culture. The archaeological record shows that from roughly 100,000 to 50,000 years ago, the pace of technological innovation among Homo sapiens began to increase noticeably. Stone toolkits no longer remained unchanged for tens of thousands of years as before, but became increasingly diverse and specialized. Long blades appeared, along with smaller but sharper spear points, tools for processing animal hides, woodworking tools, and many sophisticated stone knapping techniques. Around 45,000 years ago, in Siberia and many sites across northern Asia, archaeologists discovered bone needles with eyes for threading. Only about 2 to 3 inches long, this tiny artifact marked an enormous revolution. Instead of merely wrapping animal hides around the body, Homo sapiens could cut, sew, and create clothing that fit closely to the body, trapping a warm layer of air inside. Thanks to this, they could survive in regions where winter temperatures could fall below -22 degrees Fahrenheit. But culture did not only create tools, it also created identity. Around 51,000 years ago, Homo sapiens reached Australia. Even though this continent was never fully connected to Asia, not even when sea levels were at their lowest during the Ice Age. That means they had to cross straits dozens of miles wide using floating vessels they had built themselves. This was not simply a technical achievement. It was the result of knowledge accumulated across countless generations. Alongside technological development came an explosion of spiritual life. The paintings in Chauvet Cave in France, dated to around 36,000 years ago, or the artworks on Sulawesi Island in Indonesia, at least 51,200 years old, show that humans were no longer concerned only with food and shelter. They began telling stories through images, preserving memory, passing down experience, and building communal identity. The remarkable thing is that over the past roughly 40,000 years, the genome of Homo sapiens has changed relatively little, while technology and culture have developed at an unprecedented speed. For the first time in the history of life, a species could adapt to its environment much faster, by changing behavior rather than changing the body. This was the greatest advantage Homo sapiens had over every other human species. And precisely when culture began to evolve faster than genes, Homo sapiens possessed the final condition needed to carry out the boldest adventure in human history, leaving Africa and turning nearly the entire planet into their home. Around 70,000 to 60,000 years ago, a relatively small group of Homo sapiens began leaving Africa, possibly through the Sinai Peninsula or the Bab el-Mandeb Strait region of the Red Sea. Earlier waves of Homo sapiens had already left Africa before this, such as the fossils at Mislia and Skul Kavze in Israel, which show that humans were present outside Africa from roughly 180,000 to 120,000 years ago. Genetic models estimate that the founding population may have included only around 1,000 to 10,000 breeding individuals, and the number of people directly involved in each stage of migration may have been much smaller. Those footsteps quickly spread with astonishing speed. Around 65,000 years ago, Homo sapiens were already present in northern Australia. This is especially important because Australia was never connected to the Asian mainland, even when sea levels were at their lowest. That means humans had to cross straits at least about 45 to 60 miles wide, using deliberately prepared floating vessels. Around 45,000 years ago, Homo sapiens entered Europe, where they faced freezing winters and inhabitants who had lived there for hundreds of thousands of years. The Neanderthals. Farther east, human groups continued into Siberia, where winter temperatures could drop below -58 degrees Fahrenheit. They wore multiple layers of animal hides sewn tightly with bone needles, built shelters, stored fuel, and coordinated hunts of mammoths and reindeer. The peak of this expansion took place near the end of the Ice Age, when enormous amounts of water were locked inside ice caps, and global sea levels were about 390 feet lower than today, exposing a vast landmass called Beringia, which connected Siberia to Alaska. Around 20,000 to 15,000 years ago, groups of Homo sapiens crossed this land bridge or moved along the Pacific coast to enter the Americas. What is most astonishing is the number of environments they conquered. From tropical rainforests, African savannas, Arabian deserts, and the Tibetan plateau to the subarctic, Homo sapiens found ways to survive through knowledge instead of waiting for their bodies to change. At this point, it seemed as if Homo sapiens had become the human species that dominated Earth. But when they set foot in new lands, they quickly discovered a surprising truth. This planet did not belong to them alone. In Europe, there were Neanderthals. Across many regions of Asia, there were Denisovans. And on isolated islands, other human species still existed, each with its own evolutionary history. After a migration that lasted tens of thousands of years, Homo sapiens finally reached nearly every habitable region on Earth. The strange thing is that only about 40,000 years later, all of those branches disappeared from the fossil record, leaving behind only one name: Homo sapiens. The most famous were the Neanderthals, who appeared around 400,000 years ago and dominated Europe and Western Asia through many Ice Age cycles. They were short but extremely powerful, with broad chests, thick bones, and short limbs that helped them retain heat efficiently in cold climates. They knew how to make fire, crafted tools using the highly sophisticated Levallois technique, hunted bison, wild horses, and mammoths in groups, cared for injured individuals for years, and left evidence of burial rituals. Meanwhile, in Siberia, science uncovered an even stranger story. In 2008, at Denisova Cave, archaeologists found only a fragment of a finger bone and a few teeth. To the naked eye, it was almost impossible to know who they belonged to. But DNA sequencing technology created a turning point. Results published in 2010 showed that this was an entirely different human branch, now known as the Denisovans. Evolution on islands created other surprises as well. On the Indonesian island of Flores, scientists discovered Homo floresiensis, only about 3 feet 6 inches, 1.06 meter, tall, yet still capable of making stone tools and hunting animals. On the Philippine island of Luzon, fossils of Homo luzonensis further proved that only about 50,000 years ago, Earth was not the planet of a single human species, but a place where many human branches coexisted. each representing a different evolutionary path. Denisovans also left a similar genetic mark in many Asian and Oceanian populations. They did not completely disappear. Part of them is still living inside the genomes of billions of people. However, interbreeding is not enough to explain the whole story. DNA studies also show that they experienced long periods of low genetic diversity, which made their ability to recover from natural disasters, disease, or declining prey more limited. By around 40,000 years ago, Neanderthals disappeared from the fossil record. Denisovans, Homo floresiensis, Homo luzonensis, and other human branches also gradually left the stage of evolution. After nearly 7 million years since the human lineage split from its common ancestor with chimpanzees, the evolutionary bush that once had so many branches now had only one surviving branch left. From that moment on, Homo sapiens no longer had to compete with any other human species. And from here, instead of merely learning how to adapt to the world, humans would begin moving into a far bolder stage, changing the world itself to serve them. Around 11,700 years ago, when the last ice age ended and the Holocene began, Earth entered a rare period of climate stability. Giant glaciers melted. Sea levels rose about 394 feet compared with the glacial maximum. And forests and grasslands expanded across many continents. For the first time, environmental conditions were stable enough for a bold idea to emerge. Instead of continuing to chase food, why not make food stay with humans? Around 12,000 to 10,000 years ago, in the Fertile Crescent of Western Asia, humans began selecting wild wheat and barley plants with favorable traits for cultivation. What is interesting is that agriculture did not appear in only one place. Around the same time, other communities in the Yangtze and Yellow River basins developed rice and millet farming. In New Guinea, taro and bananas. In Mesoamerica, corn, beans, and squash. And in many parts of Africa, sorghum and millet. Humans also began changing the animals around them. Creatures that had once appeared only as prey now became stable sources of food, milk, hides, wool, and pulling power. This was the first time in the history of life that one species did not merely adapt to an ecosystem, but redesigned the ecosystem according to its own needs. Forests were cut down to open fields. Wetlands were redirected into irrigation systems. Plants and animals were selected over many generations, gradually becoming very different from their wild ancestors. As food became more stable, human groups no longer had to keep moving. The first villages appeared, then gradually grew into towns and cities. At first glance, this seemed like the perfect victory of Homo sapiens. But archaeology tells a more complicated story. Analyses of thousands of skeletons from the early farming period show that the average height of many communities declined compared with their hunter-gatherer ancestors. Diets dependent on only a few crops made nutrition less diverse. Another paradox also quietly appeared. When land could be owned, wealth could be accumulated, and food could be stored, society began to divide. Humans traded the freedom of the hunter-gatherer life for the stability of agriculture, traded relative equality for productivity, surplus, and the complexity of civilization. Yet, on the scale of the entire planet, this revolution changed Earth in an unprecedented way. The human population rose from a few million to tens of millions, and then to hundreds of millions. Forests became fields, rivers were diverted, wetlands were reclaimed, and trade networks connected lands thousands of miles apart. And it was the distance between a Stone Age brain and an increasingly complex civilization that would lead Homo sapiens to a moment when human power was no longer limited to changing the environment, but began expanding toward changing the very future of its own evolution. But the farther we move forward, the more we discover a strange paradox. The world has changed at breathtaking speed, while the brain that created all of it has remained almost the same. If we look at the skull of a Homo sapiens who lived around 40,000 years ago, it is very difficult to distinguish it from the skull of a human today. That does not mean the brain has not changed at all. But the biological changes are very small compared with the speed of civilization's development. Since the agricultural revolution began around 12,000 years ago, humanity has passed through only approximately 400 generations. A span of time far too short for natural selection to significantly restructure the most complex organ in the body. On the African savanna, a strange sound in the bushes or the footprint of a predator could determine survival. So the brain evolved to pay special attention to things that were new, unexpected, and especially dangerous. In the 21st century, that same mechanism makes it difficult for us to take our eyes off our phones. This does not happen because humans lack willpower, but because digital platforms are exploiting neural mechanisms that were formed hundreds of thousands of years ago. In ancient environments, missing a predator could mean death, while missing a beautiful scene had almost no consequence. So the brain prioritized detecting danger above everything else. Today, when news from around the world appears continuously on screens, the brain still reacts in the old way. A single headline about war, natural disaster, or crisis can attract attention more powerfully than dozens of positive stories. Another mechanism that once helped our ancestors survive is the tendency to prioritize people who belong to our group. But in a society connected by more than 8 billion people, that mechanism sometimes contributes to polarization, prejudice, and the spread of misinformation. The brain did not evolve to process thousands of opinions every day from people it has never met. And it was certainly not designed to face social pressure from millions of people on the internet. The brain shaped in the Stone Age did not only help humans survive, it also built telescopes to explore the universe, decoded the human genome, created quantum computers, and developed artificial intelligence. And now, for the first time in nearly 300,000 years of human history, technology is no longer only changing our living environment. It is beginning to turn toward our own bodies and brains. Are we preparing to create an entirely new kind of human? From a small group of hunter-gatherers in Africa to a global civilization, Homo sapiens was not the strongest, the fastest, or the smartest species in any single sense. Every turning point in the history of Homo sapiens opened new opportunities, but also created challenges never seen before. Today, facing climate change, artificial intelligence, synthetic biology, and the journey into space exploration, we once again stand at another crossroads of evolution. For roughly 300,000 years, Homo sapiens did not win because we were the most perfect species. We won because we are the species that never stops learning, cooperating, and changing. Perhaps the greatest wonder is not how Homo sapiens rose, but that this story is still being written by us. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.